I'm looking at the two basic graphs first. Y is equal to 2 to x. Let's do that one. Let's do this one, and then let's do question number 1. And then I'll show you the other one, and then we'll do question number 2. Actually, let me give myself more room on the left. Okay, so when you're graphing this thing, so you remember when we were doing polynomial functions, we looked at the limit as x goes to negative infinity and positive infinity. You guys remember that?
Yeah.
Okay, so we're gonna do the same idea here. What happens when x goes to negative infinity of 2 to the x? Well, this is gonna be negative in the top right. So you know when you have a negative exponent, it actually makes your function flip upside down, right? So it's gonna be the same as, this is the limit as x goes to positive infinity of 1 over 2 to the x, like that. Does that make sense to you guys? Like this is if it's a negative exponent, so think of just a regular exponent. 2 to the negative 1 is equal to 1 over 2, right?
Yeah.
Yeah, okay. So that's the idea. 1 over 2 to the 1. Morning, Nico. Morning, Julian.
Morning.
Okay, so as x gets really big, this is going to go really big on the bottom. The top is going to stay fixed at 1. So this is going to head towards 0. Does that make sense to you guys? Okay, so that's as x goes to negative infinity, it's going to head towards the line 0. It's kind of like a horizontal asymptote. So, all right, and then let's do the right side. So as limit as x goes to positive infinity of 2 to the x, that just goes to infinity because this is getting bigger and bigger. Yeah. So what does the graph look like? It's going to look basically like this. It's going to head towards 0 as I go to the left. And then as I go to the right, it's going to shoot straight up. It's going to make it like a super quick arc. Let's just plot a few numbers to get an idea. So I'm just going to go 5 numbers, -2, -1, 0, 1, and +2. Remember, y is equal to 2 to the x. So if I plug a -2, that's 1 over 2 to the second, or 1/4. Right, this is 1/4. If I plug in -1, this is 1. This is 2 to the -1, or 1 over 2, so that's 1/2. If I plug in 0, anything to the 0 power is just 1. If I plug in 1, it's 2 to the first power, which is just 2. If I plug in 2, it's 2 to the second power, which is 4. 2 to the second is 4. Right, so let's plot those points.
Wait, can you explain the -1 again? What did you just say?
Oh yeah, sure. So let me just write it out slowly. So this is y is equal to 2 to the -2, right? So this is 2 to the -2, which is 1 over 2 to the +2, which is 1 over 4.
Okay, thank you.
Sure. This is the same thing, 2 to the -1, which is 1 over 2 to the +1, which is 1/2. Yeah. Let's plot those points. -2, 1/4. This is 1, this is like right over here. -1, 1/2, that's like over here. And 0, 1, that's right there. So 1 second. Okay, and then 1, 2, that's 1, 2 is here. And then 2, 4, that's over here. We just connect the dots. So you see this getting a smaller and smaller fraction, right? Next would be an 1/8 and then a 16th. It's getting really close to 0 without actually touching 0. And it just passes through those points like that. And you see it grows super fast, right? It grows, in fact, exponentially by very definition. This is an exponential function, right? It's got something with an exponent. The exponent is the variable, the x part. And so you kind of, this is like the general shape it's going to have. It's going to explode really quickly. That's because your independent variable is in the exponent. That's where the name exponential function comes from. All right, so let's move on to question number 1 on the back of your page, your second page. And all we're doing is we're just graphing a different version of y is equal to 2 to the x. So we're graphing y is equal to 2 to the x minus 1. Okay, so there's a couple of general principles that we have to recall. Remember, if we have f of x minus a number, then this is a shift to the right. Yeah. If it's f of x plus a number, this is a shift left, right? If it's negative f of x, this is a reflection over the y-axis. Yeah, let's just write this down. Or y-axis. This is a shift left by h, right? This is a shift right. And then remember, we also have f of negative x. That's a reflection over the x-axis. We also have, I'm just going to write this as a combined one. We also have f of x plus or minus h. If it's plus, it's a shift up. It's a shift up or down, right? You guys remember this? We looked at this when we did graphing. We did this with graphing polynomials, and we also did this graphing just like general functions. We did it for like x squared, x cubed, and the square root of x, stuff like that. And then we did like a bunch of combined shifts, right? And also sometimes we would put a number in the front, which would like squeeze it, or make it spread out more. Okay, so that's all that's going on here. This is the idea we want to have in the back of our mind. When we look at this function, this is just like the f of x minus h case. This one minus 1 is in the exponent, by the way. So in the back of your mind, you want to think of this as like a f of x minus 1. Right? Instead of a normal 2 to the x, I have x minus 1. So what's going to happen is it's going to take the same exact shape as the original graph, and it's just going to shift. Which way do you think? Which way do you think this minus 1 is going to make it shift?
To the right one?
Yeah, to the right one, exactly. So where it used to be 0, 1, now it's going to be 1, 1. Used to be negative 1/2, now it's going to be 0, 1/2. And negative 1, 1/4. Now 1, 2. I'm sorry, 2, 2, and 3, 4. So like that. So this is the exact same picture, just shifted to the right by 1. And that's it. If you want to, you can graph both on the same graph, and you'll just see that it's going to look like this. Just a little bit above. Okay, this graph is actually closer maybe to the original, but that's the general idea. Okay, that's number 1. Let's do number 2, and then we'll look at the next type after that. This was 2 to the x. Now I'm going to look at 1 over 2 to the x. Also an exponential function, right? This is also an exponential function because, again, the dependent variable is in the exponent. The only difference now is you have a fraction less than 1, right? So now if you think, what happens as limit as x goes to infinity, or let's do negative infinity first. F of x is 1 over 2 to the x. Well, negative, remember, flips it, right? But I'm already on the bottom. So what happens when I flip this guy is it's equal to the limit at x goes to positive infinity of a regular 2 to the x. which is equal to infinity. So this time as I go negative, it's going towards infinity. And limit as x goes to positive infinity of 1/2 to the x. Well, that's equal to just 0, right? Because this is the same as 1/2 to the x. As x gets really big, this is a smaller and smaller fraction. And so to the right, I'm going to go to 0. To the left, I'm going to go up. It's kind of just going to be a reflection, it looks like, of my original. Let's plot points again. -2, we'll do the same points. If I plug in -2, this is 1/2 to the x. -2 is going to make it 1/2 to the -2. Oh, let me write it out first. 1/2 to the -2. It's going to flip it, so it's 2 to the +2, which is 4. This one is 1/2 to the -1. That's going to flip it. The negative is going to flip it, so it's +2 to the 1, which is 2. 0 to the, anything to the 0 power is 1, whether it's a half or it's 2. 1/2 to the 1 power is just a half, and 1/2 to the second power is 1/4. So you see it's actually the same graph as last time, it's just reflected, right? Reflected over the x-axis. Actually, this is in alignment with what we were saying before, because 1/2 to the x power, that's the same as 2 to the negative x power. So the negative is what's flipping it over the y-axis. Oh, I just realized I think I might have written it backwards last time when I said the shifts. F of -x, this is a reflection over the y-axis. I forget which one I said. I meant y if I didn't say y last time. Okay, so let's graph the thing. Let's see, it's still at 0, 1. At -2, it's 4, so -2, 4 is up here. -1, it's at 2. At 1, it's at a half, and at 2, it's at a quarter. Something like that. So there it is. That's the graph of y equals 1/2 to the x. And if you recall, that's the same general shape as 2 to the x, it's just reversed, yeah. Okay, let's try number 2. This is y is equal to -1/2 to the x plus 2. Okay. Do you know when I taught you guys how to do the different transformations of graphs? Do you remember if we did the shifts or the reflections first? What did I tell you guys to do? Because we could do either way, but I just want to try be consistent if I can. You guys remember?
It was shifts.
Shifts first?
I think so.
Okay. Let's do shifts first then. All right, so this graph shifts which way? I have a +2, right? So for my original position, +2 means I'm going to shift up. So from this starting position of 0, 1, it's going to shift 2 up. And then a negative in the front, that means it's a reflection over the x-axis this time. So that's going to reflect it this way, down here. So I'm expecting this point to be down here. Oh, I'm sorry, wait. No, the reflection just where it was from 2 and then reflect. Okay, to be sure, let's just check. Let's see what happens. So let's make a quick table here. Here's x, y. So if I plug in 0, this is going to be a 1, but -1, right? +2 is going to give me +1. Wait, did I calculate that correctly? -1 plus 2 is +1. Yeah, that's right. +1. Okay, let's see. So my original graph, this one, from my position, it's going to be +2. Wait. Reflected means it goes this way. And then +2. Actually, you know what? I take it back. I do want to reflect first, I think. Yeah, let's reflect first. If I shift first, I go 1, 2, and then, yeah, that's more confusing. Let's reflect first. If I reflect this guy, it's going to put me right here, right? It's going to put me down at -1. And then shifting 2 up, that takes me to where I want to be at 1. Does that make sense? So if I was to take this graph and I reflect it, let's do it in 2 stages. So reflection first will take me right here. At instead of 1, 1/2, it's going to be 1, -1/2. And instead of 1, 2, 1/4, it's going to be 2, -1/4, like this. And then here, this would be -1, 1, 2 here, and -2, 4 here. Right. So just the reflection first. That's that negative part. And then I'm going to shift that thing up. So the final graph I'll draw in red. So shift up 1, 2, 1, 2. That takes me to +1, which is where I want it to be. And then this one shifts up 2. So 1, 2 is right over here. And then 1, 2 is right over here. And then from here, -1, 1, 2 is right at the origin axis. And 1, 2 is right at -2. It's like this. So something like that. So the red is the final graph. Okay, what if we had gone 2 up? Oh, we could have done the 2 first. We would have ended up here. And then you just got to treat this line as the reflection point here. So, which would have been fine. I just kind of confused myself. But if I did my original shift, it would have brought me this point 1, 2 up here, right? And then this is the new axis now. You got to think of the whole axis is shifting, and then you would have reflected, and then you ended up at this point. So we could have done that first. Shift, and then, so shift to take us to this kind of shape, and then reflect it to take us to this kind of shape. Well, except it crosses here, so this kind of shape. Right. Okay with you guys? Any questions so far? Okay. Since I don't hear anyone, I'm gonna stop this recording and move to the next question.